Hello YouTubers, this is the Math Help channel. Today's video is about the unit circle. More importantly, how to memorize the unit circle. Most of my seniors out there are learning more advanced topics in trigonometry relative to that of which they learned in their sophomore year and junior year of mathematics in high school. This is, like I said, this is primarily just about how to memorize unit circle and be able to calculate trig functions, such as, like, if I asked you, sine of 30 degrees, you should be able to tell me that's 1/2, or tangent of 5 pi over 4, you should be able to tell me that that's equal to 1, things like that. I'm going to show you those patterns that will make memorizing this unit circle so much easier. I personally can fill out a unit circle, all three components, and those components are, remember, your degrees, your radians, and your coordinates. Personally, for me, I can fill out a unit circle in about 1 minute and 29 seconds. Completely. I can't guarantee you that you'll be able to do it that way, but I guarantee you this: if you commit these patterns to memory, you should be able to fill it out relatively quickly, probably about 3 minutes or so, maybe faster, with some practice. So without further ado, let's go ahead and jump into the unit circle itself. Okay, what I'm going to first start and do, I'm just going to fill out a unit circle. So, alright, and pardon my drawing skills, I am limited as to how well I can draw. All of these are considered your radii, or the radius of the circle, coming from the center. Now remember, your unit circle, the unit circle, remember, is a circle of radius 1. Okay? So that means each point, let me move this closer so you know what I'm talking about. Each point here, 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 and here should be 1 of some sort. Okay? Now, it looks like we have a little bit of a glare, so let's get that out of there. There we go. Okay, so here's how we're going to do this. So I'm just going to fill out all the degrees. Now, the degrees are, you have 30, 45, first of all, 0 degrees, 30, 45 degrees, 60 degrees, 90 degrees. Okay, actually we're not going to be able to read that, are we? So let's make this a little bit bigger so we can read this. So you have 0, 30, 45, 60, and 90. Okay. Next quadrant would be 120, 135, 150, and 180. And you'll notice that each quadrant is 90 degrees because these angles of each quadrants are 90 degrees apart. The axes are perpendicular to each other. Okay, then we have 210, 225, 240, 270, then 300, 315, 330, and 360. Okay, I'm going to go about this. I'm going to fill in one component at a time, and while doing so, before I move on to the next one, I am going to discuss the patterns here. Okay, so, and excuse the animal that's in the back. I don't know what he's doing. So, all right. So you'll notice that primarily the pattern, and the only pattern that I know of for degrees that makes this the simplest way to remember, is if you start at the beginning of each quadrant, if you go from that starting angle to the next one, that's 30. So plus 30, and then plus 15, plus 15, plus 30. And that works every time. So if you started here, you add 30, you get 30 degrees. Then you add 15, you get 45. Then you add 15, and then you get 60. Then you add 30, and then you get 90. Pretty straightforward. And that happens all the way around, so you just do it again. Plus 30, plus 15, plus 15, plus 30. So the pattern really for degrees, and I recommend that you write this down because I'm going to be erasing this so I can write the other patterns down. Degrees, so it's just really 30, 15, 15, 30, and you're just going to be adding these in each quadrant in that pattern. So 30, 15, 15, 30, 30, 15, 15, 30. So that means plus 30 to the 180, we give me 210. And it's right there. Pretty straightforward, right? Not much to it. So you should, with that pattern, you should be able to have the degrees memorized probably within a couple minutes. Not too much. You just got to, it's all about committing the pattern to memory before actually trying to memorize it. So this is the pattern all the way around. Now remember, the 30 degree, the starting here, that's at the beginning of each quadrant. So as soon as you arrive here, we start the pattern over. 30, 15, 15, 30. Now we start over. 30, 15, 15, 30. Okay? Okay. The next component, trying to figure out what would be the best one to do next, and I think I'm going to give coordinates. No, you know what? I'll do radians. I'll do the radians. Coordinates really are not going to be that terribly difficult. All right, our coordinates. Now, the coordinates come from the, if you guys remember, the 45, 45, 90 right triangles and the 30, 60, 90. That is in reference to the ratios of the sides to the angle. So what that means, well, if I were to draw a 30, 60, 90 triangle, and if I write this as a 1, then this would be root 3, and this would be a 2. So if we were to evaluate all the trig functions from this, like if we did sine of 30, we get 1 over 2. That's kind of what I'm talking about. And that's where all of these values are coming from. So get comfy. The 30 degrees. And this is going to, and I'm just going to do the first, well, you know what, I'll go ahead and fill it out. So the first one, this is root 3 over 2, comma, 1/2. Then this one is root 2 over 2, comma, root 2 over 2. Then we have 1/2 root 3 over 2. This one is, as I said, remember, is 0, 1, because its radius from the center to the edge of the circle is 1. Let's tilt that up just a little bit. There we go. Okay. Okay. And then we do it again, but now let's go in the opposite direction. But remember, remember that this first quadrant is both positive coordinates. So both x and y will be positive. This quadrant will be, the x will be negative and the y will be positive. So then you have negative 1/2 comma root 3 over 2. Let's write that a little bit bigger. Okay, and then negative root 2 over 2. Oh, and then root 2 over 2. And then this one is negative root 3 over 2, comma 1/2. Now you'll notice, watch this real quick. Now, one thing to remember, yeah, hold on, let me write this, -1, 0. Let me go ahead and point this out that, no, this is for that right there. Okay, for these coordinates, √3/2 is always paired with 1/2. See that? 1/2 is always paired with √3/2. And √2/2 is paired with itself. And this is going to be the same all the way through. Okay. So what I'm going to do here is we're going to employ that pattern. Watch this. So if I say, and this pattern is strictly for the x coordinates, but if you know the x coordinates based on the pattern, based on the observation that I just gave, you should be able to give the y coordinate. So if I say 3, you automatically know that that's √3, and it's over 2. You'll notice that all these are over 2's except all the angles that are on the axes. So what you do is you just, so if I say 3, you know that the x coordinate is √3/2, which means the y coordinate has to be 1/2. And if I say 2, then you know the x coordinate has to be √2/2, which means the y also has to be √2/2. Based on that alone, and the fact that this quadrant here, Q1, is both positives, x and y is positive, then you have negative positive, so negative x, positive y, negative x, negative y, positive x, and negative y. Those two things alone will allow you to memorize the coordinates really, really fast. So watch this. 3, 2, 1, 1, 2, 3. And if we just, so 3, 2, 1, 1, 2, 3. If you picked up on the pattern already, then this would be 3, 2, 1, 1, 2, 3. And in fact, you'd be correct. So let's go ahead and fill out the rest of that. So it'd be negative √3/2, comma, negative 1/2. And then for 225, it's negative √2/2, comma, negative √2/2. And then for 240, it would be negative 1/2, comma, negative √3/2. Pretty clear, right? And then this one is 0, -1. Okay. So you'll notice 3, 2, 1, 1, 2, 3, 3, 2, 1. And then 1, 2, 3. And then we have √3/2, negative 1/2, and then 1, 0. Notice how it goes just like that all the way around. Notice how I'm not including the 0, 90, 180, and 270 angles. And we're 360, same thing. Notice how I'm not including that because those are irrelevant because it's part of a unit. It's the radius. And it's going straight up, straight down, straight to the right, straight to the left. The reason I'm not for this, the radius here is still in fact 1, but you have to use the quadratic, the Pythagorean theorem. So, so there's your pattern. So you know 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. Pretty simple, right? That's your first pattern. Now here's another one. You'll notice that hold on, never mind. Okay, you'll notice that the coordinates that start with a √3 all of those coordinates are closest to the to the x-axis, and the ones that start with a 1/2 those are closest to the y-axis every time. And just by process of elimination, the root 2 over 2 is always in the middle. And you'll notice one other thing about the degrees, I'll point that out before I go on to radians, is the angles that end in 5, and there are only 4 of them, they are always in the middle. So 45, 135, 225, and 315, those all are angles that are in the middle of each quadrant, and they are 90 degrees apart. Okay. I'm gonna, since I've made quite a mess here, I hope you guys have been taking notes on this, and you have your own copy of your unit circle and your own notes on this. So what I'm going to go ahead and do is I'm going to erase this and at least fill in the degrees so we can have enough room for our third and final one, the radians. I learned this as a sophomore in high school, I think, and it took me probably the better part of a semester, or not semester, I'm sorry, an hour or so, maybe an hour and a half, to notice these patterns. And once I did that, once I committed those patterns to memory, it literally only took me about 20 minutes to completely have this memorized, and I was able to recite it. So if we remember, this is 0 degrees, 30, 45, 60, 90. Notice how I'm, besides the fact that I already have this memorized, I'm employing the 30, 15, 15, 30 pattern to each one. 120, 150, no, 135, 150, and 180. Then we have 210, 225, 240, and 270. 300, 315, 330, and 360. Okay. These are just the degrees. We've already spent a few minutes on this already. Now what we're going to do is I'm going to go ahead and put in the radian measures. Now, as far as knowing what they are, you can simply just convert them. You should know how to convert going from degrees to radians. What you do is you just take your angle and multiply it by pi over 180. You should know that already. So I'm not going to go over that. If you need me to, submit a comment to this video or a private message or something like that, and I'll get to it right away. So, okay, here we go. So 0 is, for 0, that's 0 radians. For 30 degrees, that's pi over 6. 45 is pi over 4. And 60 is pi over 3. 90 is pi over 2. Okay? 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. And 180 is pi. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. And 330 is 11 pi over 6. And 360 is 2 pi. Okay. These are all the radian measures for each degree measure on the unit circle. Now, for this to work, I actually have a couple patterns for this. I'll go ahead and give you the first one. Unfortunately, for the first pattern, you just have to memorize this quadrant alone. The 30, the 45, and the 60, along with pi over 6, pi over 4, and pi over 3. And then you just ask yourself from here to any other angle on this coordinate plane, obviously outside of the axis angles. Like if I said, let's say I want to figure out what 240 was. Well, what if I ask myself, okay, what times 30 gives me 240? Well, 30 times 8. 30 times 8 equals 240. So 30 degrees times 8 is 240 degrees. Now what if I did, now then all I'd have to do is just multiply the radian measure for 30 degrees, which is pi over 6 by 8. So then I do pi over 6, which is what 30 degrees was, and multiply it by 8. And I get 8 pi over 6, which simplifies to 4 pi over 3. And you'll notice that if we go over to 240, it is in fact 4 pi over 3. And that works as long as you start, I mean, you can start anywhere you like, but this is probably an easier way to do it. Like, for example, I can go from, well, that doesn't really help all that much. Like, you can go, what times 120 gives me 240? And that's 2. Well, if you know what 120 is, then you can multiply that by 2, but that seems kind of redundant because if we're starting from here, because that makes the multiplication easier, you're only having to memorize one quadrant. So if I said, okay, what times 45 gives me 315, that is in fact 7. And if we multiply, if we multiply 45 times 7, we do in fact get 315. And then if you take its radian measure, pi over 4, and multiply it by 7, you do get 7 pi over 4, which is the radian measure for 315. And as you can see in the background, my cat has decided to interrupt our video with him chasing his tail. Anyway, so that works all the way around. So if I know what so 30 degrees, what times 30 degrees gives me 210? Well, that's 7. So if we take the radian measure for 30 degrees, multiply it by 7, I get 7 pi over 6. And if we go over to 210, it is in fact 7 pi over 6. So that's one pattern. Now, for this second one, you have to memorize the first quadrant, unfortunately. I'm sorry. But you'll notice that all the angles, all the radians that end in 6, that have a denominator of 6, are all closest to the x-axis, and all the angles that have a denominator of 3 are closest to the y-axis. And by, again, process of elimination, the ones that have a 4 are in the middle. Now, you'll notice this. Starting here, 1, 2. Now, all of these you'll notice have pi. So right now, part of this pattern, I'm going to ignore pi for right now. 1, 2, 2, 3, 3, 4. Notice those first 3 repeated, and the last one does not. 5, 6. 1, 2, 2, 3, 3, 4, and 5, 6. So that statement, along with the one I said earlier about the 6's closest to the x and the 3's closest to the y, that's as easy as it gets. And then for the third quadrant, it's the exact opposite pattern. 7, 6, well, similar. 7, 6, 5, 4, 4, 3, 3, 2. That's how that works. Any questions with that? Now, the fourth quadrant I thought was pretty, this pattern I noticed, this was actually the very first one that was brought to me. This was by my Honors Algebra 2 teacher. Take the denominator. Now remember, 3 is closest to the y, 6 closest to the x. Take the denominator, multiply it by 2, which is 6, and then minus 1. That equals the numerator. Remember, you always have to have pi. So 3 times 2 is 6, minus 1 is 5. If we do that again over here, times 2, which is 8, minus 1 is 7. You do it again up here, times 2, 12, minus 1 is 11. Those are your patterns for the radian measure. Now, with all of those patterns in mind, with radians, with degrees, and with coordinates, take this time to commit those patterns to memory, or the ones you feel are necessary. If you have your own patterns, great. Then go ahead and spend some time committing those to memory. Once you feel you are comfortable with that, with these patterns, what you can do is draw out your own unit circle, and it's just a coordinate plane. Draw a circle, and then you draw 3 radii in each quadrant, and see how fast you can do it. Most schools, their math classes that learn this are asked to fill it out within 5 minutes. They typically have a quiz, and they have to fill it out in 5 minutes or less. So, I mean, I guess that's it. If you guys have any, if you guys have noticed any other patterns, the ones that I did not mention, feel free to add it in the comment section. I'd be interested to find out what those are, so I can spread those to my seniors. And if you have any general comments, please leave a comment below. Or if you'd like me to do any other math-related videos, leave me a private message or comment below, and I'll get to it as soon as I can. Thanks again for watching, and have a great day.